Hi, so in this example, we're going to select a SQL data source. And I'm just going to point you to my SQL server. I'm not going to specify the database. I can, but I'm just going to leave it blank and let my context engineering do the heavy lifting for me there. And I'm going to go to the talk page. It's a very simple design of VerbaGPT, so easy to use and intuitive. And I'm going to ask my question. But the question I'm going to ask today is anything but easy. This is inspired by a post that I saw, I believe, on LinkedIn, that sort of argued between the supremacy of this new AI, which is large language models, and traditional AI. So I was like, well, I think these new language models can also do traditional AI. And so what I'm going to do here is I'm going to ask you the question: apply a neural network approach to predict rings. So I have a database on my SQL server that has a table called abalone, and that table has a column called rings. Okay, so all I'm asking, I'm not even telling it which database to go to, which table to go to. All I'm asking is very straightforward in English: apply a neural network approach to predict rings. Give me the R2, so I'm assuming it'll be able to understand that that's R square, and compare it to a linear regression approach. This is not a trivial problem. I don't care, what level of analyst you are or data scientist or whatever. This takes some doing to code this, and I'm curious to see how far we can get with GPT-4. I mean, this is an experimental question, very complex question, and let's see what kind of answer we get. And best of all, with VerbaGPT, all of that heavy duty processing is happening locally. So the LLM does not have access to the underlying data at all. Not a single row of data it has access to. So that's what makes this solution pretty amazing and very different from what's out there in the marketplace. There's hardly anything out there that basically handles all the processing locally on your hardware. Okay, so here we go. So it's answered the question and a very nicely formatted answer. So let's take a scan here. Look at that. It is actually applying a neural network. Not only that, it is actually taking a categorical variable and doing one-hot encoding on it. That is amazing. And this is not magical, by the way. Once again, it doesn't have any access to the underlying data. So this is all happening through context engineering, and VerbaGPT has a framework of embeddings that comes with it that makes it very easy for the users to be able to provide exactly the information they want the LLM to have, like column names and stuff like that. Okay, so then it's doing this into features and target, training and testing and validation. That's awesome. That's the gold standard of creating these models. Fitting a neural network model, fitting a linear regression model, making predictions, and then perfect. This is a perfect sort of pathway of doing that analysis. So let's execute it. And by the way, this is an editable window. You can edit the code and execute it. And there we have it. On this data set, it's called an abalone data set. It's a very popular data set in data science. The neural network R-square is 55%, or 0.55, and the linear regression R-square is 0.54. This is kind of mind-boggling that a large language model with just this prompt, okay, was able to go to the right database, go to the right table, figure out the right features, apply the models that I asked it to, and give me the comparison of those models. Yeah, I've created a lot of these models in my life, and this just is amazing to me that it's able to do that. So if this piques your interest, check out more at verbagpt.com. Subscribe to this channel. We'll be posting more videos. And if you're interested in getting your hands on VerbaGPT yourself, we are making it available to organizations and individuals with interesting use cases. So reach out to us on verbagpt.com. Thanks for watching and stay tuned for more.